Brains. What movie is that from? 40%. No, that's from I don't know. Borderlands 1. The old weird dude and the cat and the shack. Because he. Right? No, it was from a DLC from Borderlands 1. That was pretty random. All right, everybody hush. Let's get going here. Homework. Questions on the homework before we grade it?
I do have a question, though. Who is Nathan? Why did he get 87 chair jail?
Because he's absent. We wanted to pick on him.
Oh, okay. I was about to say, what did this man do?
All right.
7 specific.
Questions on the homework. 1 through 9. Number 3 looks like this. You have a circle. It's the one where you have a secant. The secant is x. I'm sorry, tangent. Tangent is value x, and you have a secant. And the two parts are 3 and 4. Did I get that right, Danny?
They always say secant.
Okay. So Danny, remember the formula has 3 flavors to it. The flavor 1 is when you have an x in the middle. Flavor 2 is when you have 2 secants. And flavor 3 is when you have a secant and a tangent. Which flavor are we at? We're on the third one. The formula, if you look through your notes, says secant, the 2 pieces on it, this times this, well, let's finish it, is equal to that value squared. So 3 times 4 is, and that equals x squared. Now, how do you solve for x? Take the square root of both sides. You get the square root of 12. And if you were in Algebra 1, that would be it. But you're in algebra, or you're in geometry. Is there any perfect squares inside of 12? No. Yes, there is. Not 6. 6 is not a perfect square. It's 4. So 12 can be written as 4 times 3. What's the square root of 4? 2. So it's 2 root 3 is equal to x. There's your answer. Oh, Mr. C just did this wrong. These are not the droids you're looking for. All right, take a step back. I even confused myself there. All right, that is not the formula. The x squared is correct. Remember, the formula is, I'm sorry, I messed that one up completely. It's small piece, not times medium piece. It's small piece times the whole thing. So it's actually 3 times, not 4, but 3 times 7. And that equals to, I apologize. Oh, I messed that up. All right. 3 times 7 is 21. It's still the same procedure. Take the square root of both sides. Luckily for us, are there any perfect squares in 21? Are there any perfect squares in 21? What's 2 times 2? 4 is a perfect square. What's 3 times 3? 9 is a perfect square. 16, 25, 36. All right. There are no perfect squares in 21, so it's just the square root of 21. Boy, I messed that one up. All right. Luckily for myself, apparently I need practice on this as well, too. We have a whole day of practice on this. Any other questions on the homework? 1 through 9. Flavor 1, flavor 2, flavor 3. It is flavor 1. Now, this is the one that is a pretty straightforward one. There is. What's x times x? So we get x squared is equal to whatever 9 times 16 is. So x squared is equal to the square root. I'm sorry. X squared is equal to 9 times 16. These things just die so fast. They don't last more than a day. I don't understand. I like these ones, but they don't last. Danny, 9 times 16? Well, one thing is that 9 times 16, we know the next step is to take a square root. So instead of actually doing 9 times 16, we could leave it as 9 times 16 and then take the square root of both sides. And it ends up being, you see how much easier that was? 3 times 4, which is 12. And we're done.
Okay, my brain started. Why is that 4 doing? Is it that way in all the
Every classroom's like that.
Okay, I never sit in the back.
It only took you 1.5 years to figure that out, man. Congratulations. All right. Questions?
How do I do this?
No, Danny, we're not going to go over every single one. Number 8, let's take a look. Now, number 8 is, I mean, it's no different than the one we just did. It's just got uglier numbers. So let's just do the ugly numbers, and I'll call it quits after this one. So tell me what we're multiplying. You seriously need to work on your work ethic. Your non-existent work ethic.
Exactly.
It is somewhat easy, Danny, once you figure out what's going on.
2 and 1 4.
Yeah,
I'm going to write them all as improper fractions. So 2 1/4 is 9/4. All right, everyone else hush so we can do this. So 9/4 times, and that equals, we just change them to improper fractions. So we get 9/2x. And you'll see that this actually is, because you can see some things cross-reduce. If you left them as an ugly fraction or changed them to decimals, it would actually be uglier. That turns into, and that turns into, well, that's 12. And that equals 9/2x. Copy dot flip. Right? What goes into 9, 12. And that gives me a 4. Okay. Pretty easy. You did something wrong because you either gave me the wrong numbers or what? 9/2 and 2 1/4, 8, 9/4. And the other side was 15, 16/3. No, those are the right numbers. Where's our mistake? 3 goes to 1. That is a 3. And that is a 4. That is 12 times 2/9. 3 goes into 9. 3. Oh, we left this 3 off on the bottom. I'm sorry. So we get 2 times 4 is 8. And so we get 8/3. Okay, there we go. That's the answer in the book. 8/3. They didn't write over 3. They wrote it as a mixed number. So they what? 2 and 2/3. Yep, that's what's in the book. Cool. Now, a math teacher clearly wrote this problem because in real life, you wouldn't get all these things that cross-reduce so nicely and friendly. Wes, yes? Okay. All right, here we go. Number 1, the answer is 10.
Yes, I got it right.
Number 2, Danny, the answer was, you got that one right. Number 3, the answer was, well, we did that in class. Square root of 21. Did you do 4, Danny?
I didn't get that.
4 is 2. 5 is 6. 6 is 3√3. 7 is 8. We just did 8. You could either write 8/3 or 2 2/3. And number 9 is 5. All right, the other day when we had those other 3 formulas, we took a practice day to make sure that stuff was locked in our head. I'm going to warn you for the, 47th time. It's not that these individual lessons are bad. None of this, what we just did right there, is bad, if you at least not make mistakes like we did. The issue is that in totality, the entire chapter, it's just a heck of a lot of stuff. I mean, the shapes that we just dealt with were the same shapes we dealt with in the previous lesson, 9-6, that dealt with not segment measurements, but arc measurements and angle measurements. And so that's usually where I will see students struggle, is that they'll just simply mix things up. I ask you to calculate an arc and you calculate a segment, or vice versa. So today we're just going to do a quick brush up on what we just did. Simply practice this. We're going to do the same thing we did the previous time, which is I will show you, we'll do the whole thing in class, or as much as we can. Okay, so maybe there's a chance that Matt will actually not only do the work, but put his name on his paper, which he failed last time to do. All right, so let me stop this share and pull up the other one. Nope, that's not the one I want. I want the geometry one. Unless you guys want to go back to 7th grade.
No, I'll do it.
Well, I would take that because that would be easy math, right? All right. Who are we starting with? No, who are we starting with? We are starting with Matt.
Yes, we are.
Which is our goal is that you do know that by the end of class. So here we go. Flavor 1, flavor 2, flavor 3. This is flavor 2. Okay, so what's the formula? I hope I don't screw it up as I did previous time. No. Matt? No. The formula is the small piece times the whole piece. Small piece.
How come the small piece is bigger than the long piece?
Right. Okay, so we better not use those terminologies. The piece on the outside, how about that? So the piece on the outside, which is times the whole thing. So we get 9 times 16 is equal to the same thing on the other side. What's 9 plus 7? Okay. What's the piece on the outside? Now here's where you're going to mess it up. Times, not 8x. How did you get 16?
9 plus 7.
Okay, so what's it on the other side? 8 plus x. Okay, 8 plus x. I have to apologize. I got to do this on the computer. Otherwise, the online learners aren't going to see this. So let me rewrite that. So let's see, 9 times 16, that's the piece on the outside over here, times the whole thing, which is 16, 9 plus 7. And that equals piece on the outside on the other side, 8 times the whole thing, and the whole thing would be 8 plus x. All right, Matt, distributive property. And on the other side, you got a calculator. Keep talking, solve it. What are you going to do to both sides? I agree, and you get? Therefore, x is equal to. Could I make this problem harder? I could say, how long is the secant on the left side? How long is the secant on the left side? Okay, so that's the only way I could make it more challenging. Very good. Bree, questions? I think it's Bree that's online. No response. Okay. Who's next? Seth, could you erase what I wrote on the board, please? Danny, here we go. Is this flavor 1, 2, or 3? Number 2 is when you have the thing on the outside. It's number, and it doesn't really matter what flavor it is. I'm just trying to tie it into the formulas. Okay, what's the formula? Say that again. You can, but as long as they're the right numbers. Yeah, but 8 times 7 is not on the same line. So it's 8 times 16 is not on the line with 8. Do you see that? It is 8 times x. It is. There you go. Do you want to see some advanced math here? Everybody look at the board. What will we typically do at this point? Yeah, you see that? Because 16 is divisible by 8. So instead of doing 16 times 7, I mean, it's perfectly fine to do that. Well, I know that 16 is divisible by 8, so why don't we just divide by 8 at this step? Because I can see that math there would be easier. So we get x is equal to 2 times 7. You don't have to do this, but, and therefore just, now granted, this is a class with calculators, so, but if you were to do this by hand, you could always work smarter, not harder. There you go, Danny, good one on number 2. Yeah, but because some people wouldn't think that through, because, you know, when I taught you algebra, I would say simplify the left side, simplify the right side. Because I'm getting rid of this 8 that's attached to x. All right. Who's next? It's either Chris or Wes. Which one? Chris. You got number 3. Careful. It is 12, but it's not times x. Remember, this is that other flavor. It's the whole thing. So it's not 12 times x. It would be 12 times. You did? Then I'm sorry. I screwed that one up. 12 plus x. Sorry. This is not a good day for me. That's my 3rd mistake already. It is Thursday. And that equals Chris on the other side. And that is 18 squared, right? What is it? Oh, try that one again. No. We got to write the other side first. There you go. Check. So you said 144 plus 12x. I agree. And that equals 324. That's a big number. Subtract 144 from both sides, and we get 12x is equal to divide by 12, and we get, boom, look at that. No big deal. Questions, anyone? Danny, yes, no? Nice. Very good. Very good. That means, Wes, you are up, my man. Number 4. Now we're cooking. What? Oh, I see. I see. I got it. I'm not listening. I'm trying to write something. Why did I write 7 plus 4? 7 plus x. And that equals, he already did the 6 times 21. Okay. So what do we get on the left side? 49 plus 7x. And what did you say the other side turns into? Could we, yeah, we can't be smart on this one because it's got some addition involved, 7x. So we can't divide by 7, yes. Actually, we could. We could divide everything by 7 if we wanted to. Okay, extract 49 both sides.
77.
Oh boy, they gave us, these are math teacher numbers here. This would never happen in real life. This particular one, right? So I don't know, you know, cell phones, right? How do we get cell phone signal? No. Where are the antennas? No. No. Where are the cell phone antennas? You've never noticed this ever?
Like those big tall things in the forest?
Sometimes they even make them look like trees.
I know, and they don't even look like trees.
Right. But anyway, so you got a circle, right? Well, I don't know if you know this, but if the tower is in the center, right, then the radio waves emanate in all, if it's an omnidirectional antenna, the radio waves generate in all directions. Usually in general terms, though, they have directional antennas. So they go in one direction. But anyway, so this circle would represent the coverage area of your cell phone tower, right? So you knew if you were outside of it, you would be interested in how far am I away from those things. So, okay, well, if we know the if the cell phone coverage stops right here and you're 6 miles away, you might be interested in how far you could go in this particular direction, like in this direction. Well, how far is that in X? So when you're in cell phone coverage, how far could you, if this was a road, how far could you drive on this road before you're out of cell phone coverage? Something like that. That was a pretty weak one, but there you go. The one with the X in the middle is far more useful because you can always measure a distance, one of them, and define the other side would be your X. Who are we on? Are we on Seth? Seth, Nummer 5. How do you say 5 in Russian? That's your goal. Tell me tomorrow. All right. If we had more than Seth that wanted to take it, we probably could have a Russian class.
Should I take it?
I think so too.
You do realize they have a different alphabet?
Yeah.
I mean, I have a whole notebook.
Oh, you do?
Yeah.
Yeah.
And I'm just like, I'm trying to.
Because I tried to do English, legit cancer. They don't tell you.
Try memorize.
They don't. Yeah, they never give you the alphabet on Duolingo, so they're just throwing you in. Like,
So they're just giving you the words.
yeah, they give you the word and they don't tell you how to pronounce it.
So here's a Russian stop sign.
You looked at Russian cursive that one time.
Yeah, I can pronounce.
So C's or S's. Well, it's not really that it's an S. It's just that, just like us,
Pronounced like
my last name is pronounced Chartier. It's spelt with a C, so it makes that S sound, right? T is T, O's and O's, but guess what that letter is?
That's staple.
Guess what that letter is?
staple is a P.
It's pi. It's the pi symbol. That's the letter P, right? So the Greek and the Russian, they're not the same, but they share some similarities. So if you're in Russia, this is a stop sign. So
My favorite one is the B's or V's. It's amazing.
All right.
Look at the B, but it's a B.
the R's are P's, right?
Yeah.
R's are the letter P. Yeah. All right, back to Seth. Go, Seth. Go, Seth.
What are we doing again? Oh, it's the seventh equation. 10x equals.
So 10 times x is 10x,
15 times 16.
which is a large number.
Number 5, I did that already. Number 5. I got 240, 15 times 16.
240.
240.
Okay. Therefore, x is equal to.
24.
That was pretty simple. Just 2 steps. Danny, you good on number 5? Pretty simple, right? I think so.
I would hope so.
All right. Which brings us up to Ethan
I got X equals
or Chandler. Ethan, number 6.
X equals 2.
Yeah, but I want the whole problem. You're probably right, but
You got like 4.
so we got 4 times.
4 times 4 plus X.
Ooh, nice job. That's your mistake. Because the formula says to take the other side when it's a tangent, when it's just a tangent, and do what with this number? Square it. So it's not 18, it's 36.
36 plus 4x equals
Wait. Do distributive property first.
16. 4x.
And that equals 36.
Subtract 16 from 36.
Yep, and that gives you. All right, now you got it right.
I don't know how I got 18.
Because you had 18 instead of 36.
Yeah, I don't know how I got that.
I don't know either. 6 times, I don't know. All right. I wrote 5, but I meant 20. Sorry.
Oh gosh.
Thank you. Because I was thinking of the answer and talking at the same time. All right, Bree, are you online yet? Are you listening?
Yes.
Okay, we good?
Yeah.
All right, you get the next one.
I didn't do my homework.
All right, do number 7 for me. Show me you can do this.
I don't know.
All right, this is flavor number 2, where you have 2 secants that go through a circle. So we'll do this secant first, this one right here. So the formula says, take the piece on the outside, which is
3.
and you multiply it by the whole darn thing, which is
8.
and then you do the same thing on the other side. It's her microphone.
So 4 times 4 plus x.
You got it. Distributive property.
16 4x and 24.
You got it. Keep going.
I don't have a calculator.
What are you doing to both sides?
Getting rid of 16.
What added to 16 is 24. It's her microphone. It's something going on with her microphone.
Oh no, that's my bird.
Oh, that's your bird? All right. That's the 4th time I was wrong and today. I just better stop.
Looks like you're like 0 for 3.
What kind of bird do you have, Bree?
I have 4 birds.
Do they talk?
None of them talk, but Dixie makes a lot of weird sounds.
We can tell they've been making weird sounds on the video. All right, so therefore, Bree, x equals?
4.
X
2.
equals?
2.
And you're done. All right, good job. Now we are on Monsieur Chandler. Okay, so we got 10x is equal to whatever 15 times 14 is, which is 210. Therefore, x is equal to. Are you really doing this on your calculator?
21.
Did you really grab your
And I have
calculator?
the answer right there, too.
All right, so why did you need your calculator?
I don't know.
All right, Danny, yes, no? Times x. Okay, that equals, this is flavor 1. So this piece times this piece equals, and then on the other segment, or chord, I should say. That's what we did. That was 210, he said. I did a little bit of algebra. We got to the answer. How do you get rid of the 10? How's 10 attached to x? How is 10 attached to x? Is there a plus, minus, division sign, or multiplication symbol between them? There is. So how do you get rid of multiplication? That's why we divided both sides by 10, and that's where the 21 came from. Divided by, yep. Math teachers, as you get from, after you leave algebra 1, then it's not that we are skipping steps. It's just that we all understand algebra 1, and we're like, well, yeah, you just divide both sides by 10. So we get away from that stuff that we said, you must do this in pre-algebra and algebra 1 of write the division bar, divide by 10. And it's just, okay, is it skipping a step? It's not really. We just, when you have an audience that understands the algebra, it just seems like extra work at this point. We all know we're dividing both sides by 10. All right, Connor, you got the next one, number 9. All right, we'll go back to the second. Perfect. Boy, you're going to get this solved before I'm even have it written. Equals 12 squared, which is 144. You're turning into a good mathematician there, Connor. Oh, I should just stop writing. Other way around, but yes. Connor, that's the fastest math you have ever talked in 2 years. Since I've known you 3 years. 3 years, right? 2 years? Since 8th grade? 2.5 years, really. That's the fastest I've ever heard you talk, and that's the fastest math you've ever done. Well done. Easy, right? No big deal, right? If I would have shown you this in 8th grade, you would have said, Mr. C, just stop talking to me. I don't want to hear this. All right, Matt wants to look at 7. Go, Matt.
All right, so I know you need to set it up with 5 times 3 equals.
No.
Okay, that's fine.
So this is the one with 2 secants. See, that's a secant and that's a secant. So the formula for 2 secants is, it's 3, but it's not times 5. It's 3 times, yeah, the whole thing. And that equals, no, I meant the other side.
Oh, 4 times.
The whole thing. Yeah. So that's the setup. That's what you got to do. All right. We are back to Matt, number 10.
Oh, come on, I'm still in number 7.
Hey, it's the same. 10 is the same as 7, just different numbers.
All right, 10 is going to be 5 times 8. Equals 6 times 6 plus x.
Other way.
6 times x plus
It's
6.
outside,
X times 6 plus
or x plus 6. It doesn't matter. All right. We're going to get quadratic here. So that's going to give me 40. It's okay. This one's an easy one. Keep talking. Just do the distributive property. Not 2x. X times x is not 2x. X plus x. All right, we got a quadratic. This is the first one. The 10 through, what did I give you, 16? 10 through 16 are the more challenging ones. Okay. All right, Matt, we want to keep x squared positive, so I don't want to move the x squared to the other side. I want to move 40. You'll see why. Because when x squared is negative, then we got to deal with a negative x squared. It's more challenging. When x squared is positive, life is good. No, it's just 40. So how do you make it turn into nothing? Subtract 40. So we get 0 is equal to x squared plus 6x. Keep going. What did you do to both sides? Minus 40. Okay. First one, everyone stop what you're doing. 10 is different. 10 gives us a quadratic equation. Every one that's a quadratic equation, at least on this worksheet, can be factorable. So we're going to factor it. Yes, you do. You just need to be reminded. We did it yesterday. There are 2 numbers here. The 2 numbers are negative 40 and 6. Do you see them? I want 2 numbers that multiply to negative 40 that add to positive 6. What are our candidates? Give me 2 numbers, multiply that are 40. Actually, it's negative 40. 20 and negative 2. Okay, does that add up to positive 6? Nope. 10 and Matt, does that add up to positive 6? Ding, 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 we have a winner. So you take these 2 numbers and you put them in here. Let me get my red pen out now. So that's x, and that 10 was positive, yes? So x plus 10. And on the other side, it's x. What was the other number? X minus 4. If you multiply these 2 binomials together, you get this one. X times x is x squared. 10 times negative 4, negative 40. That will give me a 10x. That'll give me a negative 4x. 10x minus 4x, positive 6x. We're told this equals 0. The 0 product property says when 2 things multiply together is 0, either the first one is 0, the second one is 0, or they're both 0. So you set them both equal to 0. when you set both x plus 10 is equal to 0 and x minus 4 is equal to 0 and solve them, what do you get? X plus 10 equals 0. Solve it. We get two possible answers. Yes, and you get? So negative 10 is a possible answer, or do it to the other one, or 4. One of those is the answer. Now look at the original problem. Do you see the original problem? Could x be negative 10? Could x be 4? And there's your answer. So on this particular one, final answer, just confirm, x is 4.
Okay.
We did one yesterday where when we got our two possible answers, they both worked. There will be. Hey, you just did it. Look at the number. It wasn't bad. It wasn't one of those weird ones when there was a number in front of x squared. So do you have this one written down? So when we do the next one, which is also quadratic, you'll get practice on it. We good? Questions? Can I erase this? Wes, you're up. Wes, it's you.
It should be Danny.
Let's just make sure that we got this. So we get, oops, draw. Let me catch up. X times x plus 5. And that equals 36. He's already doing some steps in his head. Okay, distributive property. So we're going to get another one of these quadratics. Matt, we good? It's quadratic, so we want to move that 36 to the other, so we want to keep x squared positive. Wes? Equals 0. It's going to take me longer to write this than it will take you to do this. All right, Matt, yes or no? Yes. So once again, we're looking at two numbers. We're looking at negative 36 and positive 5. Two numbers that multiply to negative 36 that add up to positive 5. And you don't have to do the scratch work that I'm writing right here. Most people do this in their head. All right, Matt, give me two numbers. And that doesn't add up to positive 5. So it's not 6 and 6. We'll start with 1. What times 1 is 36? Negative 36. Well, that doesn't add up to 5. How about 2? 2n, 2n, 2n. And it's got to be negative 18. Does that add up to 5? All right. What's the next number? 3. 3 and what? Yeah, it does. Negative 12. Does that add up to 5? Running out of numbers. What's the next number? Does 4 go into 36? Times?
9.
In this case, it would be negative 9. Does that up to positive 5? Hold on. So is there a way to change that so it would add up to positive 5? And the 9 is positive. There you have your two numbers. Do you see how I did that? So when you're looking at it, you're like, well, I don't know what the answer is. When you don't know what the answer, it's called an iterative process. You start with 1. I mean, clearly it's not going to be 1 and 36, but force yourself to do what I just did. A lot of people do this in their head. You don't have to do it in your head. It doesn't take that much to write the numbers down, right? But start with 1 and then 2 and then 3 and 4. I mean, 5 doesn't go into 36, but I mean, see what my process? I mean, the next one I would have done would have been negative 6 and 6, right? But we already found the answer. Okay. So we're going to write that out. So we get parentheses, 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 and I can't draw because my finger now is tired. So we get x minus 4. Where did I get that one from, Matt and Wes? From right here that we said were the answers. and then x plus 9. And this whole thing equals 0. Zero product property, set them both equal to 0. No one actually does this. They do this in their head. Set them both equal to 0 and solve. What are the two possibilities, Matt? Take the first thing, set it equal to 0. Solve it. If you said x minus 4 is equal to 0 and you solve that, what would you get? What's the relationship between that 4 and that right there? It's the opposite. When you set x plus 9 equal to 0 and you solve it, you get. So what's the relationship? As long as it doesn't say something like 2x minus 4, then it's just the opposite of what you just got, which is why most people immediately, once they factor it, they already know what the answer is. We have two candidates, 4 and -9. Which one works? Now, if this had been a 15, it still couldn't have been -9, right? The nice thing about geometry, and there's a quadratic involved, is almost always you just eliminate the negative answers. So the answer is a +4. You feeling better about that now? All right. Danny, how about you?
I have a question.
Yes, Bree.
Where did you get the 36 from?
Remember this particular flavor, right? There's 3 flavors. One where there's an X in the center. One where you have 2 secants. Looks like this. And then the third one is when you have a tangent and a secant. On the tangent one, you square this side right here. That's where the 36 comes from.
Okay, thank you.
Yep. All right. We've been skipping Micah, so Micah, you need to do one. Or do you want the hardest one? You don't want the hardest one? All right, do this one then. Actually, no, we got to skip to the hardest one. This one right here, 14. Okay, well then show us your big brain. Okay, so 9 times 10 is 90. So we get 90 is equal to, and some people would do that whole thing in their head. Other ones would simply write it out. Oh, my word. Oh. All right. So 90 was equal to what, Micah? Do what to both sides? So we get 108. Oh, this is an easy one, is equal to.
Why did you say that was the hardest one now?
Well, because we're not done. Oh, by the way, what's the answer? What? 6? What is x equal to?
6.
It's not 6.
Yeah, it's 108 divided by 18.
What is x equal to? 108 divided by 18. 6 times 8 is 4. Oh, never mind.
Yeah.
But by the way, no, I was thinking of something else. This wasn't actually a mistake. The mistake was I'm thinking of the final answer, not the intermediary answer. Okay, so we get x equals 6, but it says find the measure that's indicated. It says he. Where's he? He is right here. So therefore we get actually HE is equal to, which is 15. I was thinking 15, not 6. And I was like, no, it's not 6. Whew. All right, so that one isn't that much harder. You just got to answer one of the questions. We okay? Because we're out of time. All right, Bree, questions?
No, I'm good.
We're laughing at your bird. All right, catch you later tomorrow.
Okay, thank you.
See ya.